Hello everyone. In this video, we will be solving basic logarithmic equations with different bases, and this is the second example. Before we go over this example right here, let's have a review on the change of base formula. If we are given log of c to the base a, using the change of base formula, we can rewrite this as that would be log of c over log of a. Please remember that in this expression, the base that we have here, which is invisible, is 10. So this is actually log of c to the base 10 over log of a to the base 10. This expression that we have here is very important because most calculators are set up to the base of 10. So we can go ahead and just use this. However, we can come up with a more general expression that is equivalent to this expression that we have right here using the change of base formula. And that would be log of c to the base b over log of a to the base b. This means that this base that we have right here doesn't have to be 10 every time. It can be any number. So I write that with a variable b. This is only true when both of these bases on the numerator and the denominator would be the same. So this is the general rule for the change of base formula. Going back to the example right here, we are given log of x plus 1 to the base 3 minus log of negative 2x plus 6 to the base 9 is equal to 0. If you notice, the bases are not the same. So the base of the first one is 3 and the base of the second one is 9. In order that we can solve problems involving logarithmic equations, we need to make their bases the same. So what are we going to do here is that we are going to use the change of base formula for this expression and this expression right here. So our expression would come out Okay, so what I did was I used the change of base formula for each of these expressions. Now, looking at the bottom right here or the denominator, we have an argument of 3 and 9. Now, we need to determine what should be the base for each of these denominators that we have here so that this denominator will turn into an integer. So that value would be a 3. So we are going to change this to a base of 3, and that would be to all of them. So we're going to change all of them to the base of 3 so that we can go ahead and say that this would come out log of x plus 1 to the base 3 over log of 3 to the base 3. That means what should be the exponent of 3 so that we get 3? So that would be 1 minus, that would be log of negative 2x plus 6 over. Now, we need to determine what should the exponent of 3 so that we get a 9. So log of 9 to the base 3 is 2. So we have 3 raised to the power 2 is 9, and that is equal to 0. Now we want to get rid of the denominators here by multiplying 2 to the 3 terms of this equation. So we're going to multiply each of these by 2. I will multiply this by 2 here and by 2 as well here, so that if we do that, we can cross out the 2 and the 2 here. So the equation would come out Okay, we remember that this 2 that we have here is actually an exponent for this expression. So this expression would come out Okay, so then from here, we are going to use the quotient rule for this, which states that if we are given a log of x over y to the base b, that is actually equal to log of x to the base b minus log of y to the base b. So that we can go ahead and divide these two terms right here. And so this equation would come out We can use the area model for this to multiply this expression right here. So our equation would come out. Okay, so what I did was I multiply x plus 1 times x plus 1. I used area model for that. And I got x squared plus 2x plus 1. So what are we going to do next is we remember that if we are given this expression that we have here, we have log of y to the base b is equal to x. We can change this to its exponential form. B to the power x is equal to y, so that we can go ahead and rewrite this as 3 raised to the power 0 is equal to whatever this expression that we have on the argument. So this would come out. Okay, anything raised to the power 0 is 1. So we can go ahead and write 1 on that. And then we just have to rewrite this expression right here. We remember that we can cross multiply these two together. And then this equation would come out. So we're going to multiply the 1 by this negative 2x plus 6. And then the invisible 1 here by x squared plus 2x plus 1. So our equation would come out. In order that we can simplify this, we're going to use the zero product property. That means we need to have this side right here equal to 0 so that we can factor it out and we should be able to solve for x. So I'm just going to show the work on the side right here. Okay, if we are going to use the box and diamond for this, the factors of x squared plus 4x minus 5 would be, that's gonna be x minus 1 and x plus 5. So that if we multiply these two together, it would come out x squared plus 4x minus 5. Again, you can use the box and diamond to factor this out, and this would be equal to 0. And so we're going to use the zero product property to solve for x. So I'm just going to show the work on the side right here. Okay, so we already have two values of x. We have x is equal to 1 and x is equal to 5. Now, we are supposed to check which of these is the actual solution and which of these is the extraneous solution, or the solution that doesn't work. So we go ahead and check which of these two solutions here is the actual solution and which one is the solution that doesn't work. So I'm just going to go ahead and test for x is equal to 1. So what I'm going to do here is that I will plug the 1 into this equation that we have right here, and our equation would come out. Okay, so what I did was I plugged in the value of x, which is 1. And so if I have 1 plus 1, that's how I got 2. I plugged in the 1 here. So negative 2 times 1 is negative 2 plus 6 is 4. And we are testing if that is equal to 0. So what are we going to do next is we are going to use the change, since these two don't have the same base. So we're going to use the change of base formula, and this would come out. Okay, so what I did was I used the change of base formula. Now we are going to change their denominators to an integer or a whole number. And then we need to figure out what should be the base here such that we make this into a whole number. So both 3 and 9, which are the two arguments, are both divisible by 3. So we can change their bases to 3. So I will change this to 3 and 3 right here. And then all of them becomes 3. So we can go ahead and rewrite this as log of 2 to the base 3 over log of 3 to the base 3. That means what is the exponent of 3, so that we get a 3, so that is 1. and that is minus log of 4 to the base 3 over. We need to determine what should be the exponent of 3 such that we get a 9. So that is 3 squared. So this value is 2. So that is 3 to the second power is 9. And so we go ahead and get rid of the denominators here. By the way, this is equal to 0. We can multiply all these 3 expressions by 2 so that we can get rid of the denominator 2 right there. So I multiply this by 2. So our equation would come out okay, now we remember that this 2 right here is actually an exponent of this 2. So we can bring this up back to its exponent so that our expression would come out okay, now we are going to simplify this. 2 squared would be 4. So we have log of 4 to the base 3 minus log of 4 to the base 3. Is that equal to 0? Since both of them are like terms, so that we can go ahead and say that 0 is equal to 0. So our value for x, which is 1, works for this equation right here. Now, we are supposed to solve for the other x value, which is negative 5. So I'm just going to show the work on the side right here. Our x now is negative 5. So x is equal to negative 5. And so I am going to plug this negative 5 into this expression that we have right here. Okay, so what I did was I plugged in the negative 5. So that would be negative 5 plus 1 is a negative 4, and that's to the base 3. So negative 5 times negative 2 is a positive 10, plus 6 is a positive 16. Is that equal to 0? Now, looking at this, we have a log of negative 4 to the base 3. So we're going to ask ourselves, what should be the exponent of 3 such that we have a negative 4? That is not possible because the argument is negative. So we can go ahead and say this is not possible. This means that the only solution that we have here is x is equal to 1. And so the other x value, which is negative 5, is an extraneous solution or a solution that doesn't work. So again, our true solution is x is equal to 1. And this one is the extraneous solution. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!